For the first time, SpaceX has put the first orbital-class Starship, a prototype known as Ship 20, S20, through a routine cryogenic proof test, filling the rocket with several hundred tons of liquid nitrogen to simulate its explosive propellant. Ship 20's first cryoproof appears to have been largely successful, as Musk also confirmed from his tweet. Relative to the almost 3 dozen cryoproofs SpaceX has completed with more than a dozen other Starship, booster, and test tank prototypes over the last 2 years, though Ship 20's first major test still has some oddities. Before we get into it, click that like and subscribe button. Let us know in the comments below what you think of the progress of Starship. At the most basic level, cryogenic tanking test, whether the Starship, Super Heavy, or test tanks, and liquid oxygen, methane, propellant, or neutral liquid nitrogen are fairly simple. The vehicle is attached to pad systems, powered on, and partially or fully loaded with cryogenic fluids. Once the desired test objectives are achieved or attempted, the vehicle is then detanked, drained of propellant or LN2. Thanks to the fact that they are incredibly cold, -160 to -200 degrees Celsius, which is about -260 to -330 degrees Fahrenheit. These starships are quickly filled and chilled inside the thin steel tanks containing them. With no insulation to speak of, that supercooled steel then freezes water vapor out of the humid South Texas air, creating a layer of frost ice that generally follows the level of cryogenic liquids in Starship's tanks. Throughout that process, these cryogenic liquids inevitably come into contact with ambient temperature Starship tanks and plumbing, white hot in comparison, and then warm up, boiling off into a gas as a result. A gaseous chemical is far less dense than its liquid form, meaning that the pressure inside Starship's fixed tanks can rapidly become unmanageable after even a small amount of boil-off. To maintain the correct tank pressures, Starship, like all other rockets, occasionally vents off the gas that forms, and thus the 2 main methods of interpreting the hieroglyphics that are cryoproof tests: frost levels and venting. Compared to earlier prototypes, Starship S20's first cryoproof has been unusual. Most notably, SpaceX began loading the rocket with liquid nitrogen around 8 p.m. Central Time. Its LOX bottom and CH4 top tanks were then slowly filled to around 30 to 50% of their full volume over the next hour. However, rather than detanking, SpaceX then partially drained the methane tank, but filled the LOX tank further before leaving the LOX tank more or less filled for more than 2 hours, occasionally topping it off with fresh liquid nitrogen. Then, almost 4 hours after the LN2 loading began, Starship performed several massive vents. Ordinarily, given the hours of testing prior, those vents would have assuredly been detanked vents, effectively depressurizing Starship's tanks as they drained of fluid. However, those vents instead coincided with the rapid loading of one of several hundred more tons of LN2, seemingly topping off Starship's S20 in the process. Around that point, it's possible that SpaceX began the pressure testing portion of Ship 20's cryoproof, mostly closing the rocket vents and allowing the pressure to gradually increase to flight levels, and maybe even higher. Many months ago, when SpaceX was deep into cryoproofing the first full-size Starship prototypes, Musk revealed an operating pressure goal of 6 bar, or approximately 90 psi. Ships were eventually successfully tested above 8 bar, or approximately 115 psi, giving Starship a healthy 30% safety margin. As the first orbital-class Starship prototype, Ship 20 likely needs to hit those tank pressures more so than any ship before it to have a shot at surviving its orbital launch debut and orbital velocity re-entry attempt. Beyond the basics of cryoproofing, Starship's S20 also marked a crucial step forward on September 29th and the 30th, becoming the first ship to complete a cryoproof test with a full heat shield installed. While it's impossible to judge exactly how well S20's approximate 15,000 tile heat shield performed, views from public webcams showed no obvious signs of tiles shattering and falling off as Starship repeatedly cooled and warmed, contracting and expanding as a result. Additionally, still in contact with the air, the steel tank skin under a majority of Ship 20's tiles would have likely covered itself in a layer of frost and ice. But the heat shields appeared to have handled the invisible change without issue. It's possible that dozens or hundreds of tiles bumped together and chipped or cracked in a manner too subtle to be visible on webcast, but that can only be confirmed or denied when the road reopens and local photographers can capture higher resolution views of Starship. For now, it appears that Ship 20's first cryoproof was highly successful, hopefully opening the door for Raptor installation and static fire testing in the near future. Next time on Discover Zen, we're going to go ahead and discuss, is it possible to terraform Mars? Thank you so much for watching our video. Until next time.